It is October 28th. Today we're doing lesson 6-4. So some of you already started and tried the homework last night and you found out it's a little bit difficult. Yeah. So we want to go through how we're going to talk about operations with scientific notation. But first we just want to do a little bit of review. So arrange at least 6 of the cards in place value order to represent a 3-digit number. So what this is saying is one of these is going to be one place value. Another one is going to be a different place value. Another one's going to be a different place value. So how in the world could we do this to represent a 3-digit number? At least a 3-digit number. So like 1 times 10 to the first. This first card that we see here. What does that actually represent? 10, right? Well, so 1 times 10, or 10 times 10 to the first power is 10. So then 1 times 10 is just 10. So that could be our tens place. We want to arrange 3 cards, at least 6 of the cards they say, but we want to put them in place value order. No, coffee on the test. It's the worst thing possible. Casualty. Well, that's going to sound funny in the video. Yes, I spilled my coffee, which is the worst thing ever. And it's all over the Math 7 tests. Alright, we're fine. Cassidy's test will just dry out. Right? Alright, bring it back in. Bring it back in. Thank you, a little rude, but thank you. So, what card up here is our largest value? Olivia?
1 times 10 to the second.
1 times 10 to the second, right? So I can take one of these cards, but that would represent 100. Do we want 100 or do we want more than 100?
More than.
Okay, well, how many hundreds do we want then?
4. 17.
Well, look at what we can work with. So if you want 4 100s, wouldn't you need another 1 times 10 to the second, and another 1 times 10 to the second, and another 1 times 10 to the second?
So we have 1 times 10 to the 8. We don't have enough for 7. No. Yeah.
So that then would give us 400. So we'll say that's in our hundreds place.
So 410.
So then we already said that 1 times 10 to the first, that just gives me a 10. But how many 10s do we want?
17.
Well, if we want 17, then we're okay to just leave that with 110. So now we've got 410, but we need a 1's place value.
Ooh.
Nate?
Wouldn't 1 times 10 to the 0?
1 times 10 to the 0, what's that equal?
1.
1. So then if I put another one there,
2.
so now we've made 412, right? But how would these actually combine? Would we add them? Would we multiply them? That's what we want to look at in this lesson, is how do we combine numbers in scientific notation? So that is what we're going to be working with today. Who that tried the lesson, where did you start to struggle and have issues?
All of it.
Well, that doesn't really help with specific feedback.
Around question 9 and 10.
You got to 9 or 10. That's kind of far, actually.
What?
It's like you made it kind of far.
Adding, subtracting, multiplying, or dividing large.
So one thing I found out is the audio still plays through. I don't think I can adjust the audio here. So I'm probably and if I forget, try to remind me. If I'm letting the video play, it plays the audio through the computer and records the audio, even if it's not playing in our classroom. So if I miss it and the video's playing, remind me, hey, you might want to pause that, because then we can just scoot through the video like this.
You can mute your video, mute your computer, right? Just mute your
I need to play with that stuff more. So here's what we do with multiplication, with addition. So to add or subtract them, we see that the addition is going to happen to both the base values, and since my powers of 10 are the same, well, guys, this 6 times 10 to the 4th, that would be 6. Move your decimal. 1, 2, 3, 4. So that's 60,000. 2 times 10 to the 4th is 20,000. So really it's just 60,000 plus 20,000, which is going to give me 80,000. So that will really just be 8 times 10 to the 4th. So when your powers are the same and you add the expressions, you just add the bases, keep your 10 to whatever power it is. So what about with subtraction? What would we have to do before we would be able to subtract? What would we have to make happen?
Do you have to make it negative?
What do you see here that is happening that's important? It was the same as what we had last time. Baylor?
Subtracting. Oh my god.
It's subtracting, but what about the numbers? We have 2.5 times 10 to the negative 9th and 2.1 times 10 to the negative 9th.
I honestly have no idea.
I know.
Okay, Nate.
You would cancel. you would cancel the two exponents.
What do you mean cancel?
They're the same.
So do they go away?
Yes, they will.
No. Oh wait. This is multiplication. So you would add two, right?
What are you
I'm
doing?
asking you. Baylor, do you know now?
I think you would still have to do the exponents because if you just subtract 0.5 minus 2.1, that's not
What is this
probably going to be your answer because you still have to give the exponents.
So this one's not on your paper, but you do have one very similar to this on your paper. Notice, notice that your powers of 10 have to start the same. To add or subtract, your powers of 10 have to start the same. So we have 10 to the negative 9th, 10 to the negative 9th, and since they start the same, they end the same, and all you do is the operation with the bases, the 2.5 and the 2.1, and you utilize the fact that this is subtraction, so you apply the subtraction, and you keep your 10 to the power.
That's what I was trying to get to.
That would be scientific
I
notation.
know, you were just kind of tripping up over your
That
words a
would be
little bit.
scientific notation, though.
Well, then we could make it scientific notation by moving my decimal over and then changing my power. So we wrote down the rule yesterday that when we move the decimal left, we moved our decimal left here, or sorry, we moved our decimal right.
We lowered, we highered our,
Here's the thing, we're negative though, so since we got more negative,
we go down.
we
to
go
negative
down.
8.
So when you move the decimal right, your power goes down, but that doesn't necessarily mean get closer to 0. It means it goes down. So it went down by 1, so now we're at negative 10. Because we've given ourselves an extra space that we have to go left when getting back to the real number.
So would it go down to negative 8 if we went to the right?
Yeah, so, but that wouldn't be scientific notation. That wouldn't help us. Yeah, but if you wanted just to play with it, then you could put 0.04 times 10 to the negative 8th. Because if we took our decimal left, the power would go up, which actually takes us from negative 9 to negative 8.
So that, would that be 0. So what? So 0.4. If we had that 0.4 times 10 to the negative 8th power.
No. We have 0.4 times 10 to the negative 9.
So can we write it as 4 times 10 to the negative 8th power?
4 times 10 to the negative 10th. It's right here in front of you, man. So when you move the decimal right, we physically moved the decimal so that we could get 4 instead of 4 tenths. Our power goes down, it decreases, but since we're negative, it gets more negative. Right?
Are there questions like this on the
Yes.
So are you gonna have to make it into the thing? Scientific?
Yeah, you always have to end in scientific notation. So once you do the math, make sure you convert it back into scientific
And
notation.
are there any questions where you have to do like the actual answer to the scientific notation, like say
It'll say right in standard form or right in scientific notation. Looking at how we would then, our rules, this is what's in your notes. So you have the addition property, you see the arithmetic, and you see the algebra. So the algebra shows you. This, I think the algebra is almost more useful because it shows you if I have A and B, both of my powers of 10 are 10 to the n, so they match. All I do is combine A and B, and I keep my power of 10. Seth?
What is that, like, awkward E, the triangle, and...
Oh, that has to do with Greek life, because we were talking about it in Foundations.
That's omega.
It's sigma delta phi,
Oh,
but
yeah.
it's not.
I knew that.
So our Greek schedule on Fridays, the alpha, beta, gamma, delta, those are Greek letters. That's why we call it the Greek schedule. We could talk about that more later. We got to get through our lesson.
So, do you know the
Yeah.
alphabet?
Alpha, beta, gamma, delta, epsilon, zeta, theta. Yeah.
Yeah.
I get tripped up, but yes. So then, subtraction, same thing. You have these subtraction properties in your notes. I would refer back to these when doing your homework. If you are struggling on your homework, your first line of help is your notes that you took during class. Capture this, and so go ahead and try that first example. We are combining, actually we're looking for the difference. Sorry, so we have, and I always mess up saying these, we have like deuterium and tritium. Tritium I say correctly, but deuterium, I'm guessing with that. So we want to see what is the difference between their masses. Tritium has a mass of 5.0224 times 10 to the negative 24th. Now, the important thing here is deuterium contains 1 proton and 1 neutron. So we need to look at what is the proton mass and what is the neutron mass. So how could we find the mass of deuterium? How could we find the mass of deuterium? Olivia? We add them, right? We take a proton plus a neutron. So we really are just going to add these two values right here. Well, since they already have the same power of 10, we have 10 to the negative 24th, 10 to the negative 24th. I know that when I add them, my 10 to the negative 24th will stay the same. All I have to do is add my base values, the 1.6726 and the 1.6749. Did you add them already?
No. Wait. Did you say that you
Hold on. Hey, so Lily's talking. You're not.
Did you say that you add the two 10 to the negative 24th?
No, so the powers, to add or subtract, your powers of 10 have to start the same. If they're not the same, you have to make them the same before you can add or subtract. Then they stay the same.
Okay.
So they both started at 10 to the negative 24th. We just keep it 10 to the negative 24th.
Okay.
So what we're trying to figure out is what is the base value out here when we add the 1.6726 and the 1.6749, and we get, it'll be 3 something. So who's got it? Grayson? Or Jack? First time I said that this year.
3 and 3,465 thousandths.
You didn't carry the one. Yeah, I did.
Yeah, you did. I think. Or did you get something different?
No, yeah.
Why don't you add them?
Oh, wait, no, never mind. Hey, never mind. You carried one.
Try this one, too.
Maybe
No,
you
wait.
carried too many.
Wait, no.
Yeah. No, he missed the one. He didn't carry the one.
And then the calculator will tell us.
It's
1.672.
right. Yeah, if you're gonna carry the one.
75.
Maybe next time.
You read it wrong.
Just the calculator helps, right?
The calculator is stupid.
So right now, all we know is that deuterium is 3.347 times 10 to the negative 24th. How do we find the difference between their weights? We're talking about atomic mass here, so I shouldn't really say weight. Weight and mass are different, as you guys are learning.
How'd you write it like that?
I changed the ink type because I think it kind of helps some of you guys see like numbers versus letters and stuff. So I changed the ink type to calligraphy. I normally forget to do that. I just discovered it like a week ago. But yeah, it does look cooler. So if we want to find difference, what's difference? Tell me to do. Ella? Subtract. So to find the difference, we're going to take our bigger mass, subtracted by our smaller one. So which is heavier here, tritium or deuterium? Which is heavier, tritium or deuterium? Tritium. They both have the same power of 10. We see 10 to the 24th for tritium and 10 to the negative 24th for both of them. So we'll just subtract. So we need to do 5.0224 times 10 to the negative 24th minus 3.347. 5, yeah, sorry, I didn't write it up here. There's a 5 there. Times 10 to the negative 24th. Again, the first thing you should do so you don't forget about it is write your 10 to the power the same as it was. Ella, you got my difference?
I did.
Okay, what is it?
1.6749 times 10 to the negative. Yep.
1.6749 times 10 to the negative 24.
That's just the new.
Will you?
Okay, so what you could really do to make it easier, like cut off some subtraction, could you just take the 10 to the negative 24th power off of there and then just add it onto the bottom?
Yeah, as long as you can remember to do that.
Okay.
I'm not going to suggest that to you, but if that works for your brain, then sure. Gentlemen, can we hold it together? I can rearrange the seating chart. That's real easy. I don't like to because I like you to be able to sit by who you want to sit by. But if you can't hold it together, that's the option.
I thought we changed the thing where
She's right. The answer is the neutron mass.
The answer is the mass of the neutron. So what does that actually tell us then? If deuterium had 1 proton and 1 neutron, then tritium must have
Let's try.
if the difference was the mass of 1 neutron, then tritium still has 1 proton,
And 2 neutrons.
but it has 2 neutrons. So now based off that observation of Lily, we know that tritium has 1 proton, 2 neutrons. That's where the tri comes from.
Try.
It's got 3. 1 proton, 2 neutrons. 3 combined.
Oh yeah, we
And
could
that's
just
a,
put the period seal. That would be much more.
A root, stem, root, whatever you want to call it.
He's gonna try.
Try this on your own. Order of operations work left to right because we have addition and subtraction, so same operation. So left to right.
Use the calculator to solve or never mind.
Do the addition.
Oh, okay.
Then once you find the sum, do the difference. They all start with the same power of 10, so this is nice for us.
Did I get it right?
You gotta do it.
Wait,
I did it. Done. I got it.
I don't think I did.
I feel like I'm really good at this. This is really fun. I really just
So when we do the sum, because we're working left to right, Rye, what'd you get for your sum?
Oh shoot. I got 10.2.
So you got 10.2. Now that's not in scientific notation. Does it matter right now? No, because that is a working number. That's not our final answer. We still need to subtract away the 2.2 times 10 to the 5th. So when I do that difference, I now get 8 times 10 to the 5th. Is that in scientific notation now?
Yes.
Yeah. So now we're good. So don't worry about scientific notation until you get to your final answer. Oh, do you have a question or you just go? I'm gonna use cards.
Yeah.
Questions?
Especially
Now I will say, if you want to write this properly, it's better to keep parentheses around your scientific notation expressions so you don't get confused. It's good to keep them grouped together. So, I've kind of already given this away by saying what we need, but is it possible to add or subtract when we have two numbers in scientific notation with different powers of 10? Taylor?
I don't know if this is correct, but yes, you can, because if you're adding, I think you just need to add the powers of 10 together and the numbers, like
So look back up to here. When we added, did we add the powers, or did the powers stay the same? They stayed the same. So the powers don't get added, they stay the same only because they started the same.
Can't you make them the same?
So this is, so the answer they're going for is it's possible, but we have to change it back into either standard form or change it to have the same power first. There's no easy way to do it when the powers are different. So you'd either change them to make the powers the same, or you just put them in standard form.
Yeah, how do you do that? Wouldn't that be like
We're gonna see that here in just a second. So yeah.
No, I'm good.
No,
No, I was thinking it, but then you just said it, so.
That we're gonna do it.
Yeah.
So that leads us.
You can use what you know about multiplying power.
Okay.
that'll sound interesting on the board.
In our power work, when we multiplied, so now we're multiplying, right? There's no gap between the parentheses. That means we have to multiply. Try to pick this back a little bit, see if I can. Obviously, anyone watching the video is going to see the answer already. What did we do with our powers when we were multiplying? So let's say we just had 10 to the negative 5th times 10 to the 11. Our bases, like 10 there, is the same, but our powers are different, and we're trying to multiply them. When we multiplied with powers, what did we actually do to the powers? Huh? We add the powers. So this actually became 10 to the 6th because negative 5 plus 11. So here we do the same thing. You want to start by just multiply your beginning values, your 2 and your 3. Then deal with your 10 to the powers. But when we multiply them, we actually add their powers together. So that gives us 6 times 10 to the 6th. So we just take it one step at a time. We do the first values, the 2 and the 3. Then we multiply with the 10 to the powers. Now, if we do division, we're multiplying again. Sorry, we have one more multiplication. So we do our 6 and our 4. This is going to be times 10 to the... Well, if we added 4 and negative 7, negative 3, right? But when we multiply 6 and 4, we get 24. So we get this 24 times 10 to the negative 3. We have to convert back to scientific notation. So we take our 24 times 10 to the negative 3. We take its decimal, right?
And then you move it over 1.
We move it over 1 to the left, and when we move left, our power increases, which actually gets closer to 0 and gives me 10 to the negative 2.
Oh, that's easy to find out. It's 0 and 2400.
Right, but we want our answer in scientific. So if we wanted our answer in standard form, then it would be 0.024, right? 24 thousandths.
Yeah.
Questions? You'll do this a lot on your homework, where once you combine them, you then still have to do a little bit of conversion to put them into scientific notation. So I would almost write this again in your notes, our decimal, if we move it left, like we just did up here, if we move it left, the power increases. If we move our decimal left, the power increases, which the opposite then is true. If we move it right, the power decreases. And then there is the rule, which is, it's in your notes, but it's on the back. Because how I had to space things to fit on the front or the back. Yeah.
So for division, would we be subtracting the exponents?
Well, is that what we did previously? Yeah. So once we get to division, it will just be subtracting. So this is kind of gross.
Dust mites.
Dust mites, real living things. Probably not, but well, maybe, but on a microscopic level. So the joke is that they saw that they were being looked at in a microscope, but bugs can't see that you're looking at them. At least they don't like really have cognitive thought. So if we think about the length of a dust mite being 2.5 times 10 to the negative 4th meters. If a carpet has 1,000,000 dust mites and they all crawled away in single file, you guys ever seen ants like in single file?
Yeah.
They do that for a reason, because if one of them then like if the line gets cut off, they know to turn around and go back. There's like a danger, like they fell off a cliff or something. So how long would this line be? Well, we have 1,000,000 dust mites, so it'd be 1,000,000 times the length of the dust mite. So really, I'm going to have the length of the dust mite 2.5 times 10 to the negative 4 times 1,000,000. But what's 1,000,000 in scientific notation? It's 1 times 10 to the 6th, right? Because it's got the 6 zeros after it. So I multiply my 2.5 and my 1. I get 2.5. Then times 10 to determine your power, since we're multiplying, we add the powers that we have. So we get 2. That's meters. And in standard form, to look at how gross this would be, it would be 250 meters. That would stretch over 2.5 football fields of dust mites. Oh, you don't want to like talk about bed bugs or something?
What if they were giant?
Let's
Let's talk about something even more disgusting.
Don't worry, we talk about a beetle on the back of the page.
Ew. Talk about what?
I've eaten a beetle.
So guys, when we talk about microscopic things,
We didn't need to know that.
bugs and bacteria are very useful.
They
taste good.
Yeah, they're tasty.
You do not. Okay.
So,
Snails are the only bugs that I
a human being, you, and you being like adolescents, probably have more. Normally, the younger you are, kind of the more bacteria that you have. So we have about 1 times 10 to the 8th bacteria in our body. If we know that 10 to the 6th gives me millions, we know this is, you have over 1,000,000 bacteria in your body.
I don't like that.
If there are 2,000 spectators at a football game,
Football game.
how many bacteria are living in the spectators combined? So try this out. I'm going to give you a minute or two to do it on your own. We have 2,000 spectators each with 1.0 times 10 to the 8th bacteria in their body. Yeah, give me a second. I've got to fix these laptops. We don't want these to be dead later. Scientific notation, please. So one thing you could do first is take your 2,000, write that in scientific notation. So that would be 2 times 10.
Fourth power. Third power.
Ooh, third. Be careful, because from where the decimal is right here, it only has 3 places to move to get back to the original. So now we really have 1.0 times 10 to the 8th That looks like a 6.
Why do we have to
10
do
to
the
the
1?
eighth.
Because would it just be 10 to the 8th?
Yeah.
Essentially.
So why do we have to do the 1?
Wait, do you want us to
Just because I write everything.
to just put it in scientific notation?
We're going to look at both. On digits, it'll tell you which to do, but right now we're just going to look at both.
So it's what?
So, we multiply my first terms and 2. 2 is the easy part, but who can talk me through finding my power? Peyton?
Well, it's 10 to the 11th power because you have to add powers because you're multiplying.
Yeah, we have to add the power since we're multiplying. So we add the 8 and the 3 and we get our 11. And then if we write this in standard form, how many zeros do I have after the 2? 11, only because there's no numbers in the decimal values. So we know that we have 11 zeros. 5, 6, 7, 8, 9, 10, 11. So then if I go back and I add my commas in to actually look at this value, there are 200 billion bacteria at that football game.
Nice.
So the next time you go somewhere in public and you think that, nah, I don't need to wash my hands, yeah, you do.
Bacteria got me like.
Ella?
Okay, so can I see a story about like a beetle experience?
Real quick, it'll lead us to our beetle problem. Oh, after the problem you want? Okay, yeah, let's do the problem first then. All right, so real quick, let's look at division, which I think you guys are pretty smart and you'll be able to figure out the division method. If I were to have you guess,
You can use what you know about dividing powers.
If I were to have you guess, stop, go back. Haha, wait. I want it to be able to go like frame by frame. All right, well, sorry that 7 over 2 is kind of flying. But what would we do? We have 7 times 10 to the 4th divided by 2 times 10 to the 9th. We don't have an idea of what our process would be? James, what else? Anyone new? Someone I haven't talked to today? Any idea? No? Zach? We haven't really talked much. You don't know?
Can you repeat the question, please?
What do you think we're going to do? If multiplication, we multiplied the first values and then
I say
Wait,
just
what's the
subtract
question?
we're dividing.
Oh,
So now,
Oh,
so,
wait.
go ahead,
We
Peyton.
subtract.
Subtract what?
oh.
But what would I have to do first?
You would have to add. No, you subtract it?
You take your 7 and your 2 and do that division. Then, to deal with your powers, you then do subtract those. So, all we do is set up 7 divided by 2 gives me my 3.5. When I look at my powers of 10, I have 10 to the 4th divided by 10 to the 9th. This is going to take 4 and subtract away the 9, so we get -5. And since my first term, 3.5, is between 1 and less than 10, we're in scientific notation. So, we just do the division and then subtract the powers.
Wait, but for the Beatles question, and do you do 1.25 over 3.1?
Hold on, just wait till we get there for a second. So again, we get our answer here, 0.6 times 10 to the 10th, in not scientific notation form. So with that 0.6, what needs to be done to that decimal, right?
It needs to be moved over. Wait, it's positive, right?
Yeah, but it doesn't matter.
No, I'm talking about
The power?
Yeah.
Oh, yeah. I thought you were talking about the 0.6. Yeah, right now it's 10 to the 10th.
So you need to move it over to the left.
Well, look, forget about the power right now.
Oh, okay.
Look at just your 0.6. To get that into what we want for scientific notation, what way do we move the decimal? To the right. So this then becomes 6.0. We move my decimal 1 to the right. When we move to the right, what happens to your power? I've heard both.
Oh no, because
It decreases.
Yeah.
When we move our decimal right, so you might want to write down the decimal rule then. If we move right, we move right, power decreases. Bless you. And then your rule, which is in your notes, right above the beetle. So, to do our beetle problem, if the beetles, size shown, stand end to end to make a line, 1.25 times 10 to the second meters long. That's how long our line is. How many beetles would there be? So Ella, if you want to tell us a beetle story, I want you to do the problem first.
I have a problem. Oh, there's a problem.
Hold on. What do you think we have to do? If we have the length of a line and the length of one beetle, and we're trying to figure out how many beetles it would take to make that line. Think about what key concept we just looked at. We just did division, right? So we're going to have to divide. So we're going to take the length of our line and divide it by the length of our beetle. So you want to set up 1.25 times 10 squared divided by 3.1 times 10 to the negative third. No. Well, yeah, for the 1.25, yeah, for that one. You don't need it for the powers of 10, though.
No.
So my first term there, it's going to be less than 1. So we're going to have to do a little bit of manipulation to it. So I'm going to write it a little bit high, just so I have some space to work. What do you get? Yeah, it's a small value, right? 0.
Yeah, 0.40. Do you want me to
Give me 2 more.
Okay. Wait, I took that in. 32222.
Wait, is it 40322? Okay, that's enough. 40322. Would it round up or down?
Round down.
Up.
3225.
So then it would be 323 if I round there. Times 10 to the Ella. Or Noah. What do I do to the powers?
I was just gonna comment on I thought it was funny that the next problem's about to start Beetlejuice.
Yeah, right. That they sometimes Pearson's kind of funny.
Yeah.
They're not funny.
The powers of 2 and negative 3. Well, my powers have to, Ella. So I'm going to do 2 minus negative 3, and minus a negative. It's addition.
It's an addition.
So we get times 10 to the 5th. But we're not in scientific notation. To get in scientific notation,
Move it to the right.
we move it to the right. So what happens to the power?
It decreases.
It decreases. So we get 4.0323 times 10 to the fourth. Because guys, think. I want you to understand why. Think about what the positive power of 5 is telling you to do. The positive power of 5 is telling you, you gotta move this decimal to the right 5 places. If you do one of the places for it, you now have done one of these powers, so you take that away, and you now get a power of 4. So, Ella, what's your story?
Okay, so it's on the New Year's, actually. So, we were doing sparklers at my friend's house. There was a beetle crawling up my neck. I screamed.
Gross.
And then it was on my finger. And then
Even grosser.
And then it flew off. And
Did you sparkle it?
It was really scary.
Yeah, you
I was
See?
just sparkler die.
The only story that I have to compete with that is I was walking my dogs on a double leash. There was a squirrel, and like sometimes I'll run with them to like let them kind of chase for a little bit, and it makes me run. And the squirrel like went one way, the one dog followed him, and then the other dog split the other way, and the squirrel like they went through a fence because it was like a wide fence, but the squirrel then came back towards me because like the dogs had both, and the squirrel ran up my leg. I was like, ah! He jumped off then, but the squirrel lived, in case you're worried. But yeah, I thought I was gonna end up with a squirrel like on my head, and like my dog is like jumping at me. It would have been terrible.
They bite your
But-
face, not the squirrel.
So, my grandma was gardening, and Japanese beetles.
Yeah,
There was
they're
a giant-
everywhere sometimes.
There was a giant trying to get out, and it was like really painful for her. So she ran inside and she got Listerine and she poured it in her ear to try to like kill it.
Yeah.
And that just made it more angry, and it burrowed deeper, like super deep, and it went through her eardrum, and then it finally died. And
She had to go to the hospital.
she had to go to the ER.
Yeah, get it
But
like
no one
removed.
was at the ER that could help, so she just had to wait for like a couple hours for someone to come and like.
Oh my god.
I don't
Hey,
think
really?
you know
Hey,
the
we
story.
got to do this problem really, really quick. I'm sorry. So, hey, we're gonna leave when we're done with this. So unless you all want to be late to your next class and deal with that. So, we have that Betelgeuse is 300 million miles away. You can look it up. We've got satellite images of it. That would be 3.0 times 10 to the 8th, because we know 10 to the 6th represents million. So tens of millions would be 10 to the 7th, and then 100 millions would be 10 to the 8th. We would divide that by the 9.3 times 10 to the 6th.
That is a big star.
No, 10 to the 7th. We get a value less than 1. Yeah. So here, really quickly, just for you guys to have it in your notes and see it, that's the math we do. We get our answer not in scientific notation. Then we have to convert to scientific notation, and that's what we get. I will see you guys later.
So